In this video, I'll show the changes for Overgrowth Alpha 143, which you can try if you've pre-ordered. In Overgrowth, a lot of animations end in a different position than they start, and this movement needs to be reflected in the game logic, such as the collision sphere and the camera target. Previously, this was done automatically by analyzing changes in the character's center of mass, but this was too imprecise for some animations. For more precise control, I added support for mobility bones, which are animation nodes that specify the logical movement of the character. Blog comments often point out that they get no results when they Google terms I use, like mobility bones. This is because there is no unified term for this that all animators use, at least as far as I know, so I just gave it a name that seemed appropriate. It's an animation bone that controls the character's mobility. Next, I worked on the AI to teach it some more of the player's moves, like rolling out of falls and throwing after an active block. I'm trying to make the base enemy AI act like an experienced player, so that they can win about 50% of the time in a fair one-on-one fight. Once that's done, it will be easy to change the parameters of each opponent to fit the difficulty curve. I also added a simple finite state machine to the enemy AI to support shifting goals. For example, this AI character starts out with the goal of following his patrol path. Once he sees you, he starts trying to pursue and defeat you. If you deal enough damage, and he has friends nearby, he might decide to run off and bring an ally back to help. This kind of AI is really simple to code, but we can get pretty interesting behavior by layering different goals. The last feature I worked on is support for cascaded shadow maps. This is very popular in mainstream games because of a few great properties it has. First, it's fully dynamic. You can move around objects in the light source without any additional performance cost. Second, it can provide very high detail, which is great because people are always impressed by detailed alpha mask shadows. Third, it's very simple and easy to implement. Cascaded shadows work by combining several different shadow maps at once, with different sizes and densities. There's one giant shadow map that stretches across the whole level at low resolution, one that's concentrated around the camera at high resolution, and several in between. Here you can see all of the different shadow maps represented with different colors. Unfortunately, cascaded shadow maps have several major downsides. First, you can see the transition between different shadow maps pretty clearly as the camera moves around, especially in complicated areas. Second, shadows are all uniformly filtered. A rock that's half a mile away has a shadow just as sharp as a character that's only a few feet away, which is not realistic. Third, it requires a lot of graphics processing power. You have to draw each object several times per frame, once for each shadow map that contains it. For Overgrowth, I think baked shadows are more appropriate, especially from a gameplay perspective, since they're softer than character shadows and don't change as the camera moves. They make it a lot easier to tell the difference between foreground and background. However, the cascaded shadows are great for the map editor. They make it easier to tell how the different objects relate to each other in space, and it's just more fun to move things around when the shadows update right away. Eventually, I think I'll make the cascaded shadows turn on whenever the baked shadows are out of date, like while editing the map, and then turn off once you rebake them. If you'd like to try out the cascaded shadows in the alpha, you can set baked shadows to false in the config file. That's it for this week. If you'd like to pre-order and try the alpha for yourself, you can do that at wolfire.com/preorder. If you'd like to hear about development news as soon as it happens, you can follow me on Twitter at Wolfire.